All right, so let's begin section 9.1, which is focusing on right triangle applications. You know we're coming off of test 3, which was probably our most challenging test that we're going to see in this course. And I guess they figured, after test 3, we're going to just go back to the basics and start off a little bit slower. So in this section, we're only looking at right triangles, which is just taking us back to basic trigonometry, SOHCAHTOA, just using sine, cosine, and tangent to solve different aspects of right triangles. So let's get into it. So in our first problem, it says to use the right triangles in the given information to solve the triangle. So whenever you see something that says solve the triangle, basically that indicates that you are looking for all missing angles and sides. So it should give you at least 3 pieces of information, and then you need to go ahead and solve to find the other 3 pieces of information. So for our first problem, we're given that b equals 8, so let's go ahead and just label the triangle accordingly. This is 8, angle B is 15 degrees, and it's saying to find AC and angle A. So we're given B is 8, we're given angle B is 15 degrees. Also, we know that this is 90 degrees because it is a right triangle. So then we can figure out what our missing angle is first. So if this is 15 and this is 90, together that's 105 degrees. So then angle A must be 75 degrees. So we know angle A is going to be 75 degrees. And now we can use SOHCAHTOA to figure out what our 2 missing sides are. So if angle B is 15 degrees and we know that this is 8, then this is the opposite of angle B, and we can find the hypotenuse, which is C, using sine. So sine of 15 degrees will equal the opposite side, 8, over C. And then we can solve this and we'll get C equals 8 times sine of 15 degrees. And then we can, 8 divided by sine of 15 degrees. And then we can just plug this in to, any calculator, and then that will give you your answer for side C. And then you go back and you use cosine, or you can use tangent to solve for side A. So then tangent of 15 will equal 8 over A, because this is the opposite side, this is the adjacent side. So tangent 15 equals 8 over A. So then A is going to equal 8 over tangent of 15 degrees. And just to remember to have your calculator set in degrees mode when you are plugging these guys in, and then that will get you the correct answer. So let's work these 2 out. So we said C is going to be 8 divided by sine of 15 degrees. So then C is 30.91 degrees, since we're rounding to the nearest 100. C approximately 30.91, and then side A is approximately, this would be 8 over tangent 15, so that would be 29.86. Now, moving on to our second example, I'll go through this one a little bit faster. Again, we start out with known information, but this time we don't have angles A and B, but we do know that C is 6. We also know that side A is 4, so we can use Pythagorean theorem to find our missing side. So let's go ahead and do that first. C is our hypotenuse, so 6 squared equals 4 squared plus B squared. So 36 equals 20 plus B squared. And then we finish solving, we'll subtract 20 from both sides, and we'll subtract 16 from both sides, and then we'll get 20. So we'll get B squared equals 20. So then B equals the square root of 20, which is 2 square root of 5. So b equals 2 square root of 5. And you can, since it says rounded to the nearest hundred, we want to find that answer. So 2 times the square root of 5 will give us approximately 4.47. So b equals 4.47. And now we need to find our angle measures. So since we know side A, since that's the one that's given to us, we'll use the two sides that are given to us. So to find angle B, that's going to require cosine because we have the adjacent and the hypotenuse that are being used. So cosine of angle B equals 4/6. And then we use the inverse to solve for our angle measures. So B is going to equal cosine inverse of 4/6. And then for angle A, that's going to require us to use sine because across from angle A is 4 and C is still the hypotenuse. So we'll use sine A equals 4/6. So angle A is sine inverse of 4/6. So here we go, working these two out. Cosine inverse 4/6. That gives us B equals 48.19. And then for angle A, we're using sine inverse. And that gives us 41.81. Which, when we add these two angles up, you'll notice that they equal 90 degrees, which they should be complementary because this is a right triangle. So now, getting into some of our application problems for these right triangles. Number one says a tower that is 147 feet tall casts a shadow 148 feet long. Find the angle of elevation of the sun to the nearest degree. So for these problems, for these applications, if the picture isn't already given, I highly encourage you to start these problems simply by drawing a picture. So we have a tower, and I didn't say that it had to be a perfect picture, but it should be some kind of picture. So the tower is 147 feet high, and then it casts a shadow, and you know the shadow is going to be on the ground. That's going to be 148 feet long, and we're looking for the angle of elevation of the sun to the nearest degree. So if the shadow is laying this way, then you know the sun has to be in the sky on the other side. So here is the angle of elevation that we're looking for. So we have 147, and this is 148. So we have the opposite side of our angle. We have the adjacent side of our angle. So let's let this angle be theta that we're looking for. So we're going to use tangent. So tangent of our angle that we're looking for equals 147, the opposite side, over 148. So then theta is going to equal tangent inverse of 147 over 148. So then that will equal, we'll plug it in, tangent inverse 147 over 148. And that gives us 44.81. Well, it says to the nearest degree, so that would be about 45 degrees, which we would expect because this is really close to being an isosceles right triangle. And if it is, then that means both of these angles will be really close to 45 degrees. So number two now says a funicular carries passengers up an embankment to an observation point. If the length of the track is 55.8 meters and the angle of inclination is 36 degrees in 2 minutes, determine the height of the embankment. And the funicular, because I mentioned that you guys should draw a picture, so I wanted to give you a visual of kind of what it looks like. It's basically a little car that carries people up and down mountains, or it carries equipment up and down a mountainside. But that's what it looks like. So it tells us that the length of our track that this little object will be going up is 55 degrees, is 55.8 meters, sorry, and then the angle of inclination is 36 degrees in 2 minutes. So we're looking for the height of the indentation. We're looking for that vertical distance, how high it is from the from ground level. So we are going to be involving the opposite side in the hypotenuse of our right triangle. So that will be a sine problem. So we'll do sine of 36 degrees in 2 minutes equals the opposite side over the hypotenuse. So then h will equal 55.8 times sine of 36 degrees and 2 minutes. So then we'll plug this in, 55.8 sine 36 degrees and 2 minutes. And that gives us 32.8. So it's 32.8 meters off the ground. Problem number 3 says the state trooper is hidden 30 feet from a highway 1 second after a truck passes. The angle theta between the highway and the line of observation from the patrol car to the truck is measured. So you have the car sitting 30 feet away from the highway, and then a second passes, and this is where a truck is. If the angle, which is marked here, is measured 16 degrees, how fast is the truck traveling? So it says express the answer in feet per second and in miles per hour. So first of all, if we just figure out how many feet is in this distance, that's going to give us feet per second. Because say it travels 100 feet, well, that means it traveled 100 feet in 1 second. So it's traveling 100 feet per second. So whatever distance we get for feet in this triangle is going to be in feet per second, because that's how long it took the truck to travel. It's going this distance in 1 second. So first, let's solve that triangle that we have. So we have the triangle looks like this. It says the angle measure is 16 degrees. This is 30. We know it to be a right triangle. So we're looking for the adjacent side. So we're going to use, we have the opposite side, so we're going to use tangent. So tangent of 16 degrees equals the opposite side, 30 over a. So a equals 30 divided by tangent 16 degrees. So let's go ahead and figure out what that distance is. 30 divided by tangent 16 equals 104.62. So a is approximately 104.62 feet. So that means that the truck in feet per second is moving at a speed of 104.62 feet per second. Now we need to convert this to miles per hour. So we're going to set up a conversion table. We're starting with 104.62 feet per second. So we have feet over second to start with, and we want to convert it to miles per hour. So first, let's convert the feet to miles. We want to have miles at the top. So 1 mile is 5,280 feet. So this will cancel the feet and we'll be left with miles. So now let's cancel the seconds and convert that to hours. So we want hours in the bottom. So we can't go straight from seconds to hours, but we'll go from seconds to minutes. So you have 60 seconds in 1 minute, and then you have 60 minutes in 1 hour. So now we'll cancel the seconds here, and then we'll cancel the minutes next. So then we'll be left with miles per hour. Now we just need to multiply the numbers. So we'll do 104.62 times 60 times 60. That will give us 3,766.32. And then we need to divide that by 5,280. So divided by 5,280. And that leaves us with 71.33. So the truck is traveling at 71.33 miles per hour. So this is the speed at feet per second. This is the speed converted to miles per hour. So now part B says if the speed limit is 50 miles per hour and the speeding ticket is issued for speeds of 10 miles per hour or more over the speed limit, what angle should the trooper issue a ticket? So now we know in this situation, we're looking for the angle measure this time. This is still going to be 30 feet. We're looking for this angle measure. So it tells us that it's given when the speed is going to be 50 plus 10, so that would be 60 miles per hour. So we want this speed right here to be 60 miles per hour when it's clocked. So the problem is given to us in terms of feet here. So we can either change this into miles, we can just convert this by dividing by 5,280 and then work through the problem that way. Or we can remember that this is 1 second and we can start with the miles and just work it backwards. So what we're going to do is we're going to change 60 miles per hour to feet per second, and that will give us this side length so that we can use, and then we can use tangent to simplify this missing angle. So we'll go from 60 miles per hour to feet per second, and this will, in that distance will be this side length. So we start with 60 miles per hour. Let's see, 60 miles in 1 hour. And we're going to convert it from miles to feet first. So this is 5,280 feet over 1 mile. So then the miles will cancel. And then we need to change the hours back to seconds. So then that will be times 1 hour over 60 minutes times 1 minute over 60 seconds. So now we're doing 60 times 5,280 divided by 60, and these minutes will cancel. We can actually just cancel one of these 60s with this 60 since they're identical, and we're just going to be doing 5,280 divided by 60. So 5,280 divided by 60 gives us 88. So that gives us 88 feet per second will be the speed, the speed at which they start getting tickets. So this distance will have to be 88 feet traveled in 1 second. So now we can use these two measures to solve for our missing angle. So tangent theta equals 30 over 88. So we'll use tangent inverse. So we'll do tangent inverse of 30 over 88. And that leaves us with tangent inverse 30 over 88. That leaves us with 18.82 degrees. So once that angle measure gets smaller than 18.82 degrees, that means this distance is going to be too far and they will start getting tickets. So number 4 says a DC-9 aircraft leaves an airport from a runway whose bearing is north 53 degrees east. It flies for 3/4 of a mile. The pilot requests permission to turn 90 degrees and head toward the southeast. After the plane goes 1 mile in this direction, what bearing should the control tower use to locate the aircraft? So first, let's just draw our direction so we can see what's going on here. So first, we'll just start out with the basic north, south, west, and east. The control tower will basically consider to be at the origin where the airport is. And it says it leaves the airport whose bearing is north 53 degrees east. So it's going north. So from north, it's going 53 degrees. So starting north, then it's 53 degrees here. So this angle measures 53 degrees. Now, it goes 3/4 of a mile, so we can label this as 3/4 of a mile. And then it says it makes a 90-degree turn. So turns towards the southeast. So this angle measure is 90 degrees. And then it goes 1 mile in this direction. So this distance is 1. And it's saying what bearing should the control tower use to locate the aircraft. So now the aircraft will be down here. Let's just draw a picture. This is my plane. So here's the aircraft. And we're trying to figure out so that the control tower is here. Let's see if I can get this straight enough. There we go. So it's going to go from the control tower. It should be a direction that's going south, some degrees, and then east. So what we're looking for is this angle measure. So we know some information about this triangle. We could find this distance if we needed to. We don't need to find the distance. We really just need to figure out what this angle measure is going to be. So we know that this angle measure is 53 degrees, and from north to east, this angle here would be 90 degrees. So we can do 90 minus 53, and that will leave us with this angle measure. So 90 minus 53 is going to be 37. So this angle measure is 37 degrees. And now if we can figure out what this entire angle is in our right triangle, then that will give us this angle. And then we can, just like we did to get the 37, we'll do 90 minus this tiny angle here. And then that will give us our direction that the tower needs to turn to locate the plane over here. So we have two sides of the triangle and we're looking for an angle. So it looks like we're going to be using tangents. So if this is the angle, 1 is the opposite side, and then 3/4 is the adjacent side to the angle here. So we're doing, let's see, I'll write it down here. So tangent of our angle is equal to 1/3/4. So tangent inverse 4/3 is going to equal our missing angle. Tangent inverse of 4/3 is 53.13. So that means this full angle in this right triangle is 53.13. So let's label that. This big angle is 53.13, and we can subtract these two to get this small piece. So 53.13 minus 37 is going to give us 16.13. And then we do 90 minus this 16.13 to get this angle that's remaining. So 90 minus 16.13, and that leaves us with 73.87. So this angle measures 73.87, and the tower's again at the origin, so it's going south, and then 73.87 degrees towards the east. So that's the way that we're going to write out our final answer. It should be south, 73.87 degrees east. So number 5, the angle of inclination from the base of skyscraper A to the top of skyscraper B is approximately 11.3 degrees. If skyscraper B is 1438 feet tall, how far apart are the two skyscrapers? So we're looking for the distance between the two. Here is skyscraper A. Here is skyscraper B. And skyscraper B is a whopping 1438 feet tall. A is over here. The angle to the top of skyscraper B, so this angle here is 11.3 degrees. So we're looking for this distance. It looks like we're going to be doing tangent again. Here's the adjacent side. Here's the opposite side. So tangent of 11.3 equals the opposite, 14.38, over the adjacent side. So D equals 1438 divided by tangent of 11.3. And that leaves us with 7,196 feet away. .49. All right, so here is our last one. It says a carpenter is preparing to put a roof on a garage that's 20 by 40 by 20 feet. So 20 by 40 by 20 feet. Steel support beam here in the center is 33 feet in length and is positioned in the center of the garage. To support the roof, another beam will be attached to the top of the center beam. At what angle of elevation is this new beam? In other words, what is the pitch of the roof? So we're looking for this angle here. So we have the full height is 33, but we know that this side is starting at basically at the height of the walls, which is 20. So that means that this distance that we're left with here, only this distance is going to be 13 feet, because if we do 30 minus 20, we have 13 feet left over. So we know this to be 13, and then this distance from the wall to the center where the beam is 10 feet. So this is 10 feet, this distance. And now we're just looking for this angle measure. So we have 10, we have 13. We're using tangent because we're using the opposite and the adjacent sides. So tangent of our unknown angle is going to be 13 over 10. So tangent inverse of 13 over 10 is our question mark. So that's 52.43. So there's our angle. There's the pitch of the roof.